In this tutorial, I'm going to be drawing a simple square slab. The dimensions of 4 meters by 4 meters. And it's going to have 4 columns, each with the dimension of 0.5 meters by 0.5 meters. And they're going to be on an offset of 1 meter from the edges of the slab. I'm going to be using tools such as the grid, axes, and coordinates. I'm going to be snapping to the grid. I'm going to be using the select mode, the draw mode, and I'm going to be viewing the model in the 3D view. I'll be also defining the materials, the load cases, and the model info. And I'll be using the grid spacing under the view menu here, and I'll be also saving the file at the end as a .gen file. I'll begin by creating a new folder on my desktop. In this folder, I'm going to save my .gen files and other files that the PL package uses, which will be saved later on. Right-click New Folder. I'm going to call it Tutorial 1. Enter. Then I'm going to start the PL gen itself. Start PL gen. Before beginning, I'm going to toggle on the grid from here. And if the axes are not toggled on, then they should be toggled on through here. And the coordinates as well. These 3 tools are going to help me with my drawing process itself. Now, before I go any further, I'm going to go to the model info. I'm going to change the title here. I'm going to call it Tutorial 1. The number of Gauss points is used for boundary and internal integration. The default number is 10. However, for optimum speed and accuracy, you can change it to 4. This will obviously be better for large files when running the model. There are 2 types of solvers. There's the LU decomposition and the Gauss elimination. The default is the LU decomposition. Click OK to close the dialog box. Press Escape to refresh. Before I begin drawing, I need to adjust the grid spacing. So I'm going to go to View, Grid Spacing. I'm going to change the grid spacing to 1. Now, as you notice here, that the dimension used is L. Now, this program is a dimensionless program, meaning that whatever dimensions you use, for example, meters, you should base all your calculations or all your drawing, all your load cases on meters. If you're going to use the imperial format, then everything should be based on the imperial format. I'm going to click OK here. Press Escape to refresh. As you notice that the grid spacing has obviously changed. Now I'm going to start with the drawing process itself. So I'm going to go and select Draw. I'm going to snap to grid to help me draw much more easier. Now I'm going to start with the drawing process. The drawing process is very important. And please note the number of left clicks and the number of right clicks that I use. Basically, they're composed of 4 left clicks and 1 right click to close the object. So I'm going to start with my first left click, second left click, third left click, fourth left click, and 1 right click to close the object. Now, as you see, the model summary bar has been updated. We have 1 undefined object. Now I need to go and draw my columns. So I'm going to go to View, Grid Spacing. I'm going to change the grid spacing to 0.25. Click OK. Escape to refresh. Now I did that because the dimensions of the column is 0.5 by 0.5 meters, and they are in an offset of 1 meter from the edges of the slab. So still on the draw mode, I'm going to draw my columns, exactly the same process as I used to for drawing the slab. So 1 left click, 2 left click, third left click, fourth left click, and 1 right click to close. I'm going to do exactly the same for all the columns. Now as you notice here that in the model summary bar that it's updated itself, and now we have 5 undefined objects. So we need to define them. So I'm going to go and select the select mode. I'm going to select the slab with 1 left click, right click on it. You should see a type dialog box appear in front of you. Now you should see all these options. If for however you see slab and opening only, that means that you have used more than 4 left clicks in the drawing process. So in this case, I'm going to choose slab, click OK. As you notice, the color has changed. And now I'm going to select the columns. Select all of them at once. Right click. You should see also these options. Select column. Click OK. Escape to refresh. And now we have our objects and defined. As you notice here in the model summary bar, it has been updated. We have 1 slab and 4 columns. Now I'm going to open the 3D view so I can view the 3D model that I created, or the model that I created. Scroll in and out to zoom in and out, and hold on to the left mouse click so you can rotate or move around the object as you please. I'm going to close that for now. Now I need to go and define my materials. So I'll click on materials. As you notice that there are 2 types of materials that are default in the program, concrete and steel. You can add a new material as you please. You can add the one that you selected, or you can do the one that you selected. In this case, we're going to be using concrete. I'm gonna go to edit. I'm gonna change the values of elasticity to 26,031. Now this is based on grade 35 concrete. I'm gonna change the new or the Poisson's ratio to 0.2, and I'm gonna change the gamma to 25. Now I'm gonna click OK. Click OK to close the dialog box, escape to refresh. Now I need to define the load cases, so I'm gonna go and click on load cases. As you notice here, there's already a default load case 1. Now the load cases are very important when running the model later on, as you can choose which type of load cases you want to use during the running of the model. You have 3 choices here. You can either add a new load case, you can edit the current one that you selected, or you can delete the selected one as well. So in this case, I'm gonna go and choose load case 1, edit it. I'm gonna call it dead weight. I'm gonna click OK. Now, as you notice here, that the dead weight has been also included in the slab on weight and the beam on weight. And obviously, if you have more load cases, you can choose from the drop-down menu which load case you would like to use for the slab on weight. Now I'm gonna click OK to close this dialog box. Escape to refresh. Now I need to define the properties of the slab itself. So I'm gonna go right click without selecting it, like this. Now, as you notice here, the slab properties appear. You can either edit the thickness of the slab, and obviously the default is 0.2. You can change it to whatever value you need. You can choose the type of materials, either concrete or steel. This is obviously based on the materials that we chose or created here in the materials dialog box. In this case, we're going to be using concrete, and I'm going to tell it to include its own weight. However, later on, you can also define the pressure for the load cases later on, but this will be explained in another tutorial. So I'm going to click OK to close this dialog box. You can also do exactly the same for the columns. So I'm going to right click on one of the columns, and the column properties dialog box appears. Now, as you notice, there's a condition. You can either choose it above or below only. So I'm going to give you a preview of what that looks like. So I'm going to choose below only. I'm going to click OK. I'm going to bring out the 3D view. As you notice here, that the top half of the column has disappeared. So I'm going to close that. I'm going to click back here. Right click. I'm going to change it for this tutorial to above and below. The default height is 3 meters, and the material, obviously, you can either choose concrete or steel. In this case, we're using concrete. And I can define the user-defined stiffness. Now, the stiffness is calculated based on non-relatives such as EA over L for axial stiffness and for EI over L for rotational stiffness. However, we can modify the rotational stiffness automatically by defining the CG over here of the column. The user-defined stiffness helps analyze better in the case of having column capitals. In this case, we're not going to be using user-defined stiffness, as the user-defined stiffness has already been calculated for me based on the geometry and the material that I'm using. So I'm going to click OK to close the dialog box, escape to refresh. Now I need to save the .gif file that I've created. So I can either click on the save icon here, or I can go to File, Save .gif file. Now I'm going to go to the desktop. I'm going to choose Tutorial 1. I'm going to call it Tutorial 1. And click Enter, escape to refresh. And that's the end of our tutorial.